Hello everyone, this is Martin Envy. Hello everyone, this is Martin Envy with Planet Earth, and in this short video I'd first like to clarify 2 points which you were asking about. So I gave you a whole lot of revision questions. You have here altogether I think around 320 questions. And why I gave you, because this is everything I can ask in the exam, so there's nothing else that I can ask about really. So this is just to see the pool of questions that I can work with, and obviously some of these will appear in the exam. Now, you were asking about 306 and 308. First of all, it says commercial uses of synclines. What is that? Or the economic uses of synclines. First, we should know what are synclines, and I'm sorry if this wasn't clear in that exact lecture, but later on when we were talking about groundwater, I did mention that a little bit. So synclines are going to be basically the valleys or the bottom side of the rock folding, or the waves in the rock, and the top would be of course the anticline. So here we're not speaking about this one, we're speaking about the syncline. And what we need to know about this one is that obviously if we have these folds in the rock, they can be pretty big. They can be like tens or hundreds of meters in like size. So that's how we can imagine this one. It's really like a valley that we imagine. And obviously in this case we can have different kinds of rocks here. Some are water resistant, some are more porous or permeable, and like limestone here can act as like a aquifer, and there can be something like an aquitard layer over here down under, made of like clay. Now what this will mean, that when we have this kind of layer here that is water resistant, there can be, for example, water trapped here in the layer above. And this can of course act as like a source of water for commercial uses, so the drinking water or irrigation or whatever. And also we can think here about like where you would put, for example, a landfill or a dump. Where would you put the rubbish of Nanjing? Obviously you wouldn't like to put it in an area where the contamination could spread out. So that's how we can think about this one as well. The syncline can be a good place to store waste or hazardous materials if there is a layer over here, this one, that is water resistant. So that's one of the possible commercial uses of synclines. You can, as an engineer, think about it as a resource, a place where you can easily store hazardous materials, or it can also be a source of water. And opposite, of course, just to mention here, is the anticline. I just put anti here. And over here in an anticline, then there would be some of these areas which are storing or are able to store like oil or gas, or hydrocarbon. The other question was about the formation of mineral joints or something like that. And actually this is in the PPT, but what this would mean is that we have a rock material here. I just put here, this is a rock, and maybe there are some waves in it. Maybe it's like a gneiss or a kind of metamorphic rock, it doesn't matter. So there can be some banding in it, there can be also folds. And what can happen is that this rock will have like these cracks. So it will break into parts. So this is brittle formation. And what can happen, of course, later on, if there is like hot water coming from down under, this hot water can enter these joints, and perhaps the hot water will also have some minerals dissolved in it. So it's not only water usually, but minerals, and these can then enter these cracks that once developed, so brittle formation in the first place. And as the water moves upwards, due to its pressure and temperature, it will carry these minerals with it, but the minerals can then precipitate. So precipitation, I just put here PPC, precipitation. Usually that's how it's abbreviated, or the symbol for precipitation. And so these cracks, these joints, can be filled with the precipitated minerals, and this can be things like quartz, but quartz is not really valuable. Instead, sometimes it can be copper, gold, silver. So these joints would often be precipitation of like gold and so on. They can also be sheets or joints of minerals, then once again, which have precipitated as the water is cooling down. It's traveling there. Probably it will lose some of this mineral due to various chemical and physical properties it's going through, or how it's changing through this journey as it's moving towards the surface. So this is how mineral joints are developing.